Lecture: Electric and Magnetism. A Faraday law concept. This is our team: Muhammad HAZIQ bin AZRI, Muhammad AIDEED bin KAMARUDDin, Muhammad Faiz bin Zohri. What is Faraday's law? Faraday's law is a basic law of electromagnetism, predicting how a magnetic field will interact with an electric circuit to produce an electromotive force, EMF. This phenomenon is known as electromagnetic induction. Faraday's laws of induction explain the working principle of transformer, motor, generator, and inductor.
So, today I want to explain the relationship between the polarity of the magnet bar pole and the brightness of the bulb, also the deflection of galvanometer. So first, I tick the box of the field lines and change the direction of the magnet bar to north pole. And I bring the magnet bar toward the solenoid to observe the brightness of the bulb and deflection of the galvanometer. As you can see, the closer the magnet bar to the solenoid, the brighter the bulb it is. The deflection of galvanometer is toward negative and positive when I pull up. And then I change the polarity to south pole and see what happens. The bulb is still brighter and the deflection of galvanometer is contradicting with the north pole. It's because the polarity is changed, and first is positive and when I pull up is negative. As a conclusion, the brightness of the bulb depends on the number of the turn coil, and the deflection of the galvanometer depends on the polarity of the magnet bar.
So if we look at this picture, there is two solenoids. The upper one has a lower number of turns than the bottom one. Let's see what happens when we put this magnet bar into both of the solenoid. The upper one, the lower one. We can see that the bottom one is much brighter than the upper one. Why is it? The reason is by using the formula from Faraday's law, induced EMF is directly proportional to the number of turns and the rate of change in the magnetic flux. From Faraday's law as well, we know that EMF produces induced current. Thus, the higher the number of turns, the brighter the light bulb. This is because when the turn increase, the EMF producing the current also increase. Thus, the light bulb become brighter.
For the conclusion, more turn in a solenoid will result in the bulb is brighter, more current induced, deflection is small, more flux will cut through, and less turn in a solenoid, bulb is dimmer, less current induced, deflection is less, and less flux will cut through. Thanks. That's all.